All right, so let's talk about, let's do another example here of finding the slope of a tangent line, the derivative at a specific point, and then we'll find the equation of the tangent line that goes through that point and is tangent to the curve. In this case, we're going to look at f of x equals 1 over x and at x equals -4. So to start off with here, we are going to set up the problem. Remember that we're using the definition of a derivative, which should already be in your notes. Limit as h approaches, try again. We're off to a great start. Limit as h approaches 0 of f of a plus h. Now a, in our example here, is going to be -4. So f of -4 plus h minus f of -4. Okay, let's actually... see if that helps a little bit. All right, so that's all divided by h. All right, then we're going to actually fill in the equation here. And again, what we're trying to do is find the slope. All right, this limit is equal to the slope of the tangent line at -4. So we need to evaluate the limit. And we need to do that algebraically. So this will end up being 1 over -4 plus h minus 1 over -4. Again, that is found because f of -4 plus h, I'm just taking -4 plus h and plugging it in for x there. Okay. And then I'm taking -4 and plugging it in for x into the function. Okay, divided by h. And so I end up with limit as h approaches 0 of, okay, so let's clean this up a little bit. This is going to be minus a negative, so plus 1/4. So I have this 1 over -4 plus h plus 1/4 divided by h. Now, what I need to do is find a common denominator. Well, I need to clean this complex fraction up. Okay, so I'm going to do that by finding a common denominator. And the common denominator that I'm going to find is going to, I'm going to reason my way to the common denominator in the following way. I'm going to look at this fraction here, and I'm going to see that it has a -4 plus h, but does not have a 4, a factor of 4. So I'm going to multiply that by 4 over 4. So 4 over 4. That way it will have a denominator with a factor of 4. This fraction over here, does not have a -4 plus h in the denominator, so I'm going to give it that, but I can't just multiply by it. I have to do -4 plus h over -4 plus h, so that I'm just really multiplying by 1, but a very convenient version of 1. All right, so then, let's zoom in a little bit here. Let's see better. Okay, so now I'm going to clean this up some more. So I've got limit as h approaches 0. On top of this fraction, I've got 4. In fact, let's combine these fractions together. So I'll have 4 plus -4 plus h. So it'll end up looking like this. 4 plus -4, so -4 plus h. All divided by positive 4 times -4 plus h. All of that divided by h. Clean up some more. 4 minus 4 is 0. So that ends up being 0. And on top, I will just have h. So I'll have the limit as h approaches 0 of h, and I'm gonna rewrite this. So I'm gonna take this top fraction here in braces. I'm putting in braces, and then I'm gonna write it like this. So h over 4 times -4 plus h. All of that times 1 over h. Okay, so I'm using this property here that says if you have a times 1 over anything, 1 over b, let's say, that is the same as a over b. I'm just using it the other way. So I'm just saying this is what I started with, and I'm going to take the a thing out in front. Now I do that because it's a little bit more helpful to see what's going to happen. Right here, when I multiply these fractions, I will end up with h over h, which simplifies to just 1 over 1. And so the fraction now that I'm evaluating the limit at will be limit as h approaches 0 of 1 divided by 4 times -4 plus h. Now when I try direct substitution with 0, I will actually get a value. So I have so when I plug it in, I will get this. 1 divided by 4 times -4 plus 0. And that'll be 1 divided by -16. or we can just write -1/16. So there's my slope. So that's part A. So I've just done part A. Good job, me. Okay, there's the slope. Now let's go do part B. Part B, we're going to find the actual equation of the tangent line. Remember, we're going to fill in this point slope form. All right, the point that it goes through, we'll go get that in a second. We do know the slope, though. That's -1/16 times x. And then x1, that's got to be -4. So it's going to be +4 when we plug it in. And then what is y1? Well, that's the function evaluated at -4. If you plug in -4 here, what do you get? Well, you get -1/4. So this will be -1/4. So what do you end up with? Well, you get y equals -1/16 x. And then I'm distributing here. -1/16 times 4, that's -4/16, so that's -1/4 minus 1/4. And so your final answer here for part B, the equation of the tangent line is -1/16 x minus 2/4, so that's -1/2. And that's your final answer. So again, like I said in the first video, the work here is in the algebra. These are really make you flex your algebra muscles to solve them. But again, that limit gives us the slope of the tangent line at a given point, and we can then find the equation of the tangent line at that point.